Welcome you to Home Class TV. I and myself, Aliwi Tosin. We are taking electricity. Under which we are talking about electric current. Firstly, what is current? Current is defined as the free flow of electrons in a circuit. Current can be defined as the free flow of electrons in a circuit or a conductor. Current can be defined as the free flow of electron in a circuit. Now, when we refer to current as the free flow of electron in the circuit, we can also say that electric current is the rate of flow of current in a circuit. Electric current is the rate of flow of current in a circuit. Electric current is the rate of flow of current in a circuit. Now, current itself is denoted by I. Current is denoted by what? It is denoted by capital letter I. Current is denoted by capital letter I, and it is measured in amperes. Current is measured. It is measured in amperes. That's A. Current is measured in amperes, and we also say that current can be measured using a device known as Can be measured using a device known as ammeter. Ammeter, we say, is a device used for measuring current. Now, we said current is what? Is the free flow of electrons in a circuit. And we said electric current is the rate of flow of current in a circuit. It is denoted by I. That current is denoted by what? I. And it is measured in what? In amperes. An instrument for measuring current is called what? The ammeter. Now, we also have what we call the quantity of charge. The quantity of charge is denoted by Q. Quantity of charge is denoted by what? By Q. And the quantity of charge is measured in coulombs. Quantity of charge is measured in what? Coulombs. Coulombs. That's C. Quantity of charge denoted by Q is measured in coulombs. And our quantity of charge Q is given as Q. That's quantity of charge is given as electric current multiplied by time taken. Quantity of charge is given as what? Electric current multiplied by time taken. Now, Our quantity of charge we said is measured in coulombs, and we said that what current is measured in what? In ampere. We said our quantity of charge is denoted by Q, and our current is what? Our current is denoted by what? I, and time is what? T. So we see that our Q is equal to IT. Current times what? Times time, quantity of charge. Now let's take an example. Now let's take the first example. A 30 coulomb charge flows through a conductor in 2 minutes. Calculate the current flowing in the circuit. Firstly, let's write out our parameters. We have the quantity of charge as 30 coulombs, and we also have the time taken as 2 minutes. The SI unit for time is seconds. That's the what? The International System unit for time is what? Is seconds. So we have to convert from 2 minutes to seconds. That will be 2 times 60. That's 120 seconds. Under 20 seconds. Now, using the formula required now, we said that what? Q is equals to IT, where our Q is the quantity of charge, our I is the current, and the T is what? Time. We are given our quantity as 30, and we're given the current is unknown, and we're given time as what? Let's bracket that, time as 120. So we divide through by 120, we have this cancels this, then our current will be 30 over 120. This cancels this. 3 here 1, 3 here 4. So which means that we're having current equal to 0.25 amperes. 0.25 amperes. That's answer for that. Now let's take another question. Now let's take this question now. Example 2. A 20 microcoulombs flows through a conductor. 20 microcoulombs charge. There should be charge here. Charge flows through a conductor in 10 nanoseconds. 10 nanoseconds. Now, let's write out the givens. We are having in coulombs now. That's the quantity of charge is given as 20 microcoulombs. 20 microcoulombs, we have to convert it from microcoulombs to what? Coulombs, because the coulombs is this SI unit for quantity of charge. So which means that it will be 20 times 10 raised to the power minus 6 coulombs. 20 times 10 raised to the power minus 6 coulomb. And we're also given our time, T, as 10 nanoseconds. 10 nanoseconds, this means that what? We have to convert it from nanoseconds to what? To seconds, which is 10 times 10 raised to the power minus 9 seconds. Now, why this is done now, we are told to find the current again. Now, we said that using Q is equals to IT. Our Q is 20 times 10 raised to the power minus 6. And our I is unknown. Our I is unknown. While the I is unknown, then we have our what? Our time to be 10 times 10 to the power minus 9. Now divide through by 10 times 10 to the power minus 9. Divide through by 10 times 10 to the power minus 9. This cancels this. So we are having our I to be equal to 20 times 10 to the power minus 6 over 10 times 10 to the power minus 9. So we are having this cancels this. We have 2. So we are having 2 times 10 to the power minus 6 divided by 10 raised to the power minus 9. So you are having 2 times 10 raised to the power minus 9. For me, this is 9. Division turns to minus here. Minus 9. So that we have 2 times 10 raised to the power minus 6 plus 9. That's 2 times 10 raised to the power minus 6 plus 9 will give us 3, which is what? Our current equals to 2 times 10 to the power minus 10 to the power 3 amperes, which can further be written as what? 2 times 1000, which is 2000 amperes. Yes, 2000 ampere. Now, our 2000 ampere can still be written, depending on the options. You can say that our I, which is 2000 ampere, can be written as what? 2 kilo ampere. Final answer. So, on this note now, we come to the end of this segment. We continue our electric current. Let's call this part 1. We'll continue the part 2 in the next video. I name myself Aliwi. Thank you.